So we're going to try a real quick question to make sure that you understand and to prove what we've just learned as well. And that's a question I like to give because it shows you if you really understand acceleration, velocity, and displacement graphs or not. The question is, draw the acceleration, velocity, and displacement time graphs for a ball being thrown up in the air and being caught. So just remember, the timer starts right when the ball releases from your hand and stops right when it comes from your hand. So the answer, the acceleration is a constant negative value, and that's actually minus 9.8, and we're going to explain why it's minus 9.8 later. And the velocity graph would actually look like this, and the displacement graph would look like an upside down parabola. So if you think about what we just learned, we can apply our three levels accordingly. So let's just look at the gradient. If you look at the gradient of this, it is a constant negative gradient the whole time. Hopefully you know your math, y equals to mx plus b. The gradient here is a negative constant. And that, remember, the gradient of a velocity graph should show you the acceleration. Okay, what about the gradient of the displacement graph? The gradient of the displacement graph should show you the velocity. So if we look at the gradient here, first it's positive, and then the gradient goes to 0, and then it goes negative. So if we look at our velocity graph, that's exactly what happens. When it goes to 0, it lines up with that. So all of these will kind of make a lot more sense when you learn calculus in 12th grade math. But until then, you can use the table that we taught you to help you relate the acceleration, velocity, and displacement graphs. So let's explain this velocity graph real quick. Let's say we threw it up at 30 meters per second. So it's 30 meters per second now. And our acceleration, let's just say we'll round it up to minus 10 meters per second squared. So that means after every second, we're going to lose 10 meters per second. So after one more second, we're going to end up at 20 meters per second. After another second, we're going to end up at 10 meters per second. And then after another second after that, we're actually going to hit 0 meters per second. So when the ball reaches the maximum height, the speed is 0. So if you look at our displacement or the distance is actually going to make a parabola, as you can see. But right at the top of the parabola, our velocity is actually 0. But our constant acceleration will continue to happen. So now when it's coming back down, we have a minus 10 meters per second because, minus for the downward direction, and then minus 20 meters per second, and then minus 30 meters per second. So it's actually going to come back at the same speed that it was thrown at. So that's kind of corresponds to 30 there and minus 30 there, if we threw it at 30 to begin with. I hope you enjoyed that video. Tag a friend who has issues with these graphs, and remember, you can ask us questions anytime and we'll answer them for you. Thanks.